Okay, so this lecture is about symbolic artificial intelligence. Symbolic AI, also known as good old-fashioned AI, is a branch of artificial intelligence that focuses on using explicit human-readable symbols and logical rules for explicit human-readable symbols and logical rules for representing knowledge and reasoning. Representing knowledge and reasoning. It contrasts with modern AI techniques like deep learning, which uses statistical and data-driven approaches. Now, important concepts in symbolic AI is the knowledge representation. This is the way in which information about the world is structured so that a computer can use it to solve complex tasks. Common methods include logical representations, formal systems like propositional logic and predicate logic. These are used to give the logical representation. Then semantic networks, graphs where nodes represent concepts. So these are graphs where the nodes represent concepts and the edges, they represent the relationships between the concepts. Then there are frames. These are data structures for representing stereotype situations. Then there are ontologies. These are hierarchical structures of knowledge. These are hierarchical structures of knowledge, often used to represent relationships in a domain. These are hierarchical. Then there are production rules, if-then rules. These are if-then rules that guide the reasoning or the actions. So these rules guide the reasoning or the actions. Now, reasoning and inference, symbolic systems attempt to deduce new information, from known facts using logical reasoning. Deductive reasoning, it is about drawing conclusions from general rules. So some general rules are given and you have to draw conclusions from those general rules. Whereas inductive reasoning, it is making just the opposite, making generalized conclusions from specific examples. So you are going from examples to generalized. And here you are drawing conclusions from in deductive from general rules. Abductive reasoning, it is inferring the most likely explanation for observed facts. So you are inferring the most likely explanation for observed facts. Non-monotonic reasoning where conclusions can be withdrawn in the light of new information. So that is non-monotonic reasoning, where conclusions can be withdrawn if new information comes. The default reasoning is assuming default values in the absence of specific information. Assuming default values, you are assuming default values in the absence of specific information. Now comes search and planning. So symbolic AI often involves searching through a space of possibilities to find solutions to problems. Now there is state space search. It is about searching through all possible configurations or states of the system. Heuristic search is searching methods that use heuristics or rules of thumb to reduce the search space. Some domain specific rules there it is used to reduce the search space. Then goal-based agents, agents that take actions to achieve specific goals. So these are goal-based agents, agents which take actions to achieve specific goals. Then there are planning algorithms. These are methods for generating sequence of actions to achieve a goal. In expert systems, these are systems designed to emulate the decision-making ability of a human expert in a specific domain. So they are domain specific. Rule-based systems, systems based on a large set of if-then rules. So large set of if-then, this can be systems which are based on large set of if-then rules. And there are inference engines, which are components that apply the logical rules to the knowledge base. This apply the rules, logical rules, to the knowledge or information that is there in the system to deduce new information. Now, knowledge base, it is a structured collection of facts and rules. So it is a collection of facts and also rules. Now, logic and theorem proving. A foundation of symbolic AI involves representing problems in formal logic and using automated reasoning to solve them. A foundation of symbolic AI involves representing problems in formal logic and using automated reasoning to solve them. Propositional logic, a simple form of logic dealing with true or false statements. Then predicate logic, first order logic, it extends propositional logic by dealing with objects, properties and relations. And automated theorem provers, these are programs that automatically prove logical theorems. Now in natural language processing, early symbolic approaches to understanding and generating human language, there were early symbolic approaches to understand and generate human language. And there is syntax parsing, which is about analyzing the grammatical structure of the sentences. In semantic analysis, it is about understanding the meaning of sentences through logical forms. In knowledge-based machine translation, translating, what happens is that the text is translated by understanding its meaning rather than merely pattern matching. So understanding of meaning is there in the computer, in the program, rather than simply pattern matching. In some next lecture, we will discuss how this is done, this understanding of meaning. Now, conceptual dependency theory. This is a theory to represent the meaning of natural language statements in terms of actions and their participants. So it represents the meaning in terms of actions and participants. Problem solving. Symbolic AI is traditionally good at tackling well-defined problems like puzzles and games. So symbolic AI is good at tackling well-defined problems. Problems must be well-defined. Constraint satisfaction problems. Problems where the solution needs to satisfy a set of constraints. The solution needs to satisfy a set of constraints. Game playing. Symbolic AI has also been used in game playing algorithms such as chess, like minimax with alpha beta pruning. Now, common sense reasoning. Symbolic AI tries to encode the kind of everyday knowledge humans use to make use of the world. So it tries to encode the everyday knowledge in symbolic AI. An ambitious effort to encode common sense, CYC Project, which is an ambitious effort to encode common sense knowledge in symbolic form. It's very interesting. Then there is qualitative reasoning. It is reasoning about the physical world in terms of qualitative relationships rather than quantitative values. This is very, very interesting. Symbolic learning. Although symbolic AI is not typically associated with learning, there are techniques. Symbolic AI is not typically associated with learning. There are techniques for learning symbolic rules. So their symbolic rules can be learned. Inductive logic programming. It is a method of learning logical rules from data. Decision trees, although more commonly associated with statistical methods, they are also within symbolic frameworks. Explanation-based learning, learning by generalizing specific examples into rules based on prior knowledge. Learning by generalizing specific rules, generalizing specific examples into rules based on prior knowledge. So you are converting examples into rules. Now, cognitive architectures. These attempt to model human cognitive processes using symbolic representation. SOAR, it is a cognitive architecture that models human problem solving and learning. ACTR is a cognitive architecture that models human cognition, particularly memory and reasoning. Now, what is meta reasoning? Meta reasoning is our reasoning about the reasoning process itself. Meta knowledge, knowledge about how the system reasons or solves problems. Reflection, the system's ability to examine and modify its own reasoning strategies. Now, formal methods. Symbolic AI often overlaps with formal methods used for verification and validation. Model checking, a method for systematically checking whether a model of a system meets certain specifications. Systematically checking whether a model of a system meets certain specifications. A formal verification, using logic to prove the correctness of systems, especially in applications like hardware or software. Causal reasoning. Causal reasoning, it is representing and reasoning about cause-effect relationships. Representing and reasoning about cause-effect relationships. Causal network, directed graphs that represent causal relationships. Directed graphs that represent causal relationships between variables. Bayesian networks with symbolic reasoning extensions, probabilistic models that can be used for reasoning with uncertainty. Declarative versus procedural knowledge. Declarative knowledge, knowledge of facts, such as this, Paris is the capital of France. Then procedural knowledge, knowledge of how to perform tasks. Then uncertainty in symbolic AI, while early symbolic systems were deterministic, later work introduced methods for handling uncertainty. Probably a system that combines symbolic logic with probabilistic logic, that combines symbolic logic with probability. Fuzzy logic, a form of logic that allows reasoning with degrees of truth rather than binary true or false values. Cognitive robotics, the use of symbolic reasoning in robotics to provide robots with high-level reasoning capabilities. And symbolic grounding, the problem of how symbols, words or concepts are connected to real-world objects or experiences. High-level planning in robots, using symbolic planners to generate actions for robots in complex environments. So these fundamental concepts form the basis of traditional symbolic AI systems, and many of these ideas continue to influence modern AI research, especially in areas that require explainability and reasoning.